Yes, so what we have discussed in the last class?
The request line out becomes the most predictable.
Okay, that task I have given you. So once we discuss with the ARP and default gateway, then we will come to that point, right? Okay. So we have discussed that ping is what? Ping stands for packet internet dropper. It is used for checking the reachability purpose, for checking the connectivity purpose. So in the ping, what it does, it sends echo request packet. And when it sends echo request, it waits for the echo reply. And the time that it takes or the time it took to send the request and get the reply is called as a round trip time. Okay. Same, we have certain TTL values in the ping. So that is called as the time to leave. It means that how many devices it can cross without being discarded, that packet without being discarded. Right. Then we have discussed about the trace route also. So trace route is like coming under ICMP only, but instead of checking the connectivity, it identifies the path. What all the path that particular device or that particular data packet is taking to reach that particular destinations. Correct. And for checking the trace route command, trace route, we used to give the command as tracert, tracert and IP address or tracert with the no name. So now we'll understand with the R. What is this R? Address resolution protocol. So we'll understand this with scenario only. See, for example, if we have taken one switch, and with this switch, we have connected multiple PCs. 1, 2, 3, 4, and 5 PCs. Okay. Now we'll assign the IP addresses on the PCs. Let's say this is 10.0.0.1. This one has 10.0.0.2. This one has 10.0.0.3. Then this one has 10.0.0.4. And this one has 10.0.0.5. This is PC1. This is PC2. This is PC3. Okay, let me change here only. And this is PC4. And this is PC5. Okay. Now come to the individual PC. Desktop, IP configurations, assign the IP addresses. 10.0.0.1. So as you know that this IP belongs to class A. So if you will come to subnet mask, automatically it will take as a /A. Next, come to second PC. Desktop IP configurations. 10.0.0.2. Desktop IP configurations 10.0.0.3. Come to this one first. Desktop IP configurations 10.0.0.4. And okay. Desktop IP configurations 10.0.0.5. Now you know that whenever we try to pick for the first time, what happens? We have discussed in the first class that this is the feature of that switch where whenever first time it is getting any request messages, it broadcasts that. So we'll see how it does that. So come to simulation mode. Now we'll come to this PC1 and try to ping to PC, let's say 10.0.0.3. Okay, I'm trying to reach PC3. Okay. Now, when you will try to ping, what will happen? See, the first packet that it has generated is ICMP, and one more packet is that is called as a ARP, right? So when we ping comes under ICMP. So it sends echo request packet to get echo reply that is based on the ICMP. But Though we have given the ping command, but it is going to generate both the packets. One is ICMP also, and one is ARP also. Then what is the requirement for that? See what happens that this PC is having the IP address, right? Same as certain other PCs also having the IP addresses. But you know that when they will communicate in the LAN environment, what is required? MAC address. So this PC wants to know the MAC address of PC3 to communicate with that. But when it says that this switch that okay, I want to know the MAC address of the PC3, what this switch will tell, I don't know where is that PC3 because just it has been connected, but they have not communicated via me. That's why at present I don't have that any information regarding that. So first time when it will receive the information, so he will tell as I don't know. So what he will do, he will flood that. We call it as a broadcasting, but actual term is not a broadcast. Actual term is unicast flooding. Flooding means what? Unnecessarily sending all the things to the all other different ports. Broadcast can be like I want to send it to the all the ports, right? It is my intention. But flooding means what? It is not the intention to send, but it is not having any other option only. That's why it floods that. That's why the term is called as a unicast flooding. Okay. So now you see here that when you will check the MAC address, sorry, ARP table. So here it shows that okay, this is layer two. It means that ARP operates at which layer? Layer two. That's why it is showing you also. So what information we have? Here we have source MAC address. Source MAC address of what? PC1. And what is this? All F. All F means broadcast or flooding we can say. So what it says that I don't know. So I have to know about all that particular device's MAC address. That's why it is as that switch is not having the information. So it is sending it to the all interfaces. That's why the destination is here all F. Correct. So where you will find this all F in the ARP header. Now see here details. It is written. This is what Ethernet header. In the Ethernet header, the information is destination MAC as all F. But this is what ARP header. In the ARP header, what is the destination MAC? 0. What does it mean? This one is broadcast. Okay. And this one is unknown. Right. So like whenever it can be a question that, okay, when ARP is being sent, so we have one destination address, destination MAC address is all F, that is broadcast. So where do we have this all F? In the Ethernet header. Okay. Whereas in the ARP header, what is the target MAC? Unknown. It means here that this PC is telling that unknown, but this switch is sending it to the all, right? Because it is not knowing, it has to know. That's why it is asking everyone that tell me who is having this particular MAC address or this who is having this IP, tell me your MAC address. Correct? So what is the size of this ARP header? 28 bytes ARP header size. Okay. Now here, if you will find here, this is written as what? Opcode is what? 00001, right? Opcode is 0001. It means what? This is ARP request packet. How will you identify? 0001 means ARP request. ARP request will be always in what form? Broadcast form. ARP request will be in what form? Broadcast form. When that this message will reach to the specific PC, then what will happen? This particular specific PC will reply. If this information reaches to the PC3, PC3 will reply with its own MAC address. Then ARP reply will be in what form? Unicast. Okay, now see what will happen. Huh? We'll come to that point. Now see, deliver to the switch. Now see what switch will do. Broadcasted to all other ports. What will happen now? See, they all will drop. Why they are dropping? Because they are not having this specific IP address. Who will accept that? Only 10.0.0.3 will accept that. Now you see and check here. Now what is this? Here the target MAC address was all F. Hereby this is my target MAC address. It has got the MAC address now. Now it will reply. So when it is going to reply, what is the opcode here? 0002. When request 0001. When reply 0002. Echo request in what form? Sorry, ARP request in what form? Broadcast. ARP reply in what form? Unicast, right? So now it got the MAC address. See, this is the MAC address, and this is the target MAC address. It has received the MAC address information. Now what will happen? This particular MAC address information will be delivered to whom? To this PC1. Now see, delivered to the PC. Sorry, switch. Now it will deliver to the PC. Received. Now, once it is received, so now it is knowing the target MAC address. So what it will send? ICMP packet it will send, right? So at present, when you will check the ICMP packet, let me send first. Right? It is unicasting because ICMP levels unicasting. Now, yes, see, this is a layer 3 operating at layer 3. Source is 10.0.0.1. Destination is what? 10.0.0.3. ICMP message type is what? 8. Request. This is what? Reply. Source is what? 0.3 and target is what? 0.1. Type is 0. This is echo request. This is echo reply. Now it will reach there. This is the echo reply packet. Come into the PC1 again. Done. Now, if they have received all the information, now if you will check on the PC1, see, it is pinging, right? Now, you have to know about what all the ARP information this PC1 is maintaining. That we have to see. How will you check? ARP space -A. ARP space -A. When you will check this command, you will use on the Windows, right? When you are checking on other devices, command will change. Let's say we are checking on the router, so we have to give their show ARP. Okay. Now see what it says, that my neighbor is 10.0.0.3 and it is having a MAC address of this one. And how I am learning about this? Automatically. Dynamic means what? Automatic. Okay. So see, whatever the MAC address information it is learning, so it is not going to be stored here permanently. Again, it will be deleted after a certain time. What is that certain time? 120 seconds. I've told you, that is switch. This is Windows. Okay. There are different operating systems. That's right. Okay. Now it got that information. But again, let's say if you want to ping from PC 5 to PC2, what will happen? Broadcasting will happen, no? Because who has communicated? Only 1 and 3 has communicated. So if second time 1 and 3 will communicate, they will have a recasting. That is fine. But again, other PCs, if they will communicate, again, they require the broadcasting information. Correct? Right? So if let's say PC5 is trying to ping, again, come to simulation. Ping to 10.0.0.2. Correct? What happens? Packet is generated, ARP packet. This is ARP. Okay. ICMP. Now see. Delivered to the switch. Now what will happen? Broadcast. Broadcasted. Correct? Then again, who will reply? That specific PC will reply. Now come to real time and check now. Come to this PC. ARP space -A. Yes. Having the information. Correct? Same as if, let's say, if PC1 is trying to ping to 10.0.0.5, it will ping, right? Now you check ARP -A. So the same PC is maintaining two ARP information, two MAC address information, right? because it has communicated with two different devices. That's why. Correct? Now, okay, let's say, understand the scenario now. What happened that this particular, we tried to ping from PC1 to PC3. We tried to ping from PC1 to PC3. ARP request we have generated. It reached the PC3. Then they both have exchanged the MAC address information. They're maintaining. Fine. Now let's say if you want to ping from PC3 to PC1, again that ARP request will be required or not.
So PC3.
For the first time PC1, we have pinged from PC1 to PC3. So ARP request required, that is fine. Now, once they have exchanged the information, second time what we are trying to do, we are trying to ping from PC3 to PC1. So this time again ARP is required or not? Yes, it is not required because they have already, correct. Already they have exchanged information. The second time between them it is not required. Whoever is communicating, it is not required because they have exchanged the information. Correct?
It is after 2 minutes.
Again it will require. Correct? Now you check on the switch. Come to CLI. What we have to check on the switch? MAC address table. Show MAC address table. See what it is showing you. VLAN information. Like by default, all the switches are in common VLAN. That is VLAN number 1. These are the MAC address information. How it is learning dynamically. And this is what? Port status, port numbers. It means with what port, what device is connected, that it is showing you. So if you will find here that it is telling you that this, let's say this is F04. So with F04, what is connected? PC5. So what is the MAC address? PC5, this one. Correct? This is all the MAC address. So if you check, come to physical config fast Ethernet. Text. Okay, this is recording this one. No? Yeah.
It was PC1 FA0/5.
1 minute. Okay, this one PC1. Yeah, correct. It is F05. Yeah, we got the MAC address. 5824582. Yes, 458. Correct. And this is how it can maintain the MAC address with the associated port numbers, right? So what is this ARP? Now you understood that what happens, it is trying to ping. Whenever we try to ping, it generates one ARP packet that will be sent in the broadcast form. Then it will receive the ARP. So what actually is ARP? Yes. ARP is address resolution protocol. Okay. It is a layer 2 protocol that is used to find the MAC address of the device with the known IP address. It means here IP addresses will be known. ARP request will be in the form of broadcast, whereas ARP reply will be in the form of unicast. When PC wants to know the MAC address of the device with the known IP, it generate ARP request. Okay. In Ethernet header, destination MAC address will be all F. It means broadcast. Whereas in ARP header, destination MAC address will be all 0. It means unknown. Correct? As switch does not have the MAC address information about that particular device, that's why it sends a packet to each and every port other than the port from where it received, right? And this is called as unicast flooding. Right? So what it does, with the help of known IP address, it tries to know the MAC address of the devices. That is called as the address resolution protocol. Like we have discussed that ICMP is having a protocol number 1. Do we have any protocol number for the ARP? No, no protocol. Because it operates on the layer 3. Hmm. There also we read this. Like, because when you try to communicate, you will be communicating with the ping. Let's say you are trying with the ping. So ping is operating on which layer? Layer 3. So when you are writing ping, you have to write IP addresses only. You cannot write ping and MAC address. We can, but generally what is required, like we need to have unique logical addresses for the each devices. And for that, we prefer IP addresses, even for the local communications as well. Okay. And for the local communications, we require address resolution protocol. Even let's say finally what happens, final communication will take place at layer 2 with the help of MAC address. Let's say as of now, what we are doing that my devices are located in the same network. So it is asking the ARP from where only to the switches only. Now let's say my devices are located in different network. Okay. So again, this particular PC will require the MAC address information of that particular PC located in different network. In that scenario also, it will ask the ARP request. Right? Who will reply? We'll come to that part. That is concept called as a proxy ARP. Okay. And proxy ARP is one of the most important topic, right? The reason nowadays the question is being asked based on the proxy ARP. Okay. And if you will not understand the scenario of proxy ARP, you will always give wrong answers. Okay. So devices has IP, and for communication inside network, they require MAC address. That's why we have address resolution protocol. So ARP is a feature of IP version 4. In IP version 4, it requires this. But when we will discuss IP version 6, ARP is not required there.
So what will happen if the IP address is not present within that network?
Means?
Like there's 5 PCs and there's 5 IP addresses, and ARP packet is sent via one PC to another, but then that is not present within that.
If it is not present, it will not get a reply. They will not be able to communicate.
Which type of message we get then?
Means?
Like ARP request.
Unreachable.
There is 0002.
Because it is sending that, but it is not receiving. Or you will get request, and let's say you try to ping. Okay, fine. Come to command prompt. Let's say we will try to ping to 10.0.0.10. This IP is not existing. Or it says request timeout. Yesterday also I told you why it says request timeout, because whenever there is no problem from your side, if problem is from your side, then it will tell you destination host unreachable. Request timeout means what? I am sending it. I'm not able to receive. It means problem is not with me. Problem is with the other side. Okay, receiver side. He's not replying. That's why he's sending it. But that particular device is not existing only from where he will get the reply. That's why it is telling you request timeout, request timeout. I am waiting for the reply, unable to get any reply. Correct? Like whatever the communication is we are sending, it is based on the MAC addresses only, no? Whatever transmission is happening in the LAN environment is based on the MAC addresses only. But we operate. For that, you need to require the MAC address information, target MAC address. You have to know, right? The target MAC address of the devices. Then you have to specify that. But as I told you that everything, Aman, if you're not getting my voice, okay, let me ask with others. Everyone, confirm. Am I audible to all?
Yes.
Okay, then Aman, there is problem with your side. Check your connectivity. Okay. Now see what is written in the PPT. What is written here? Address resolution protocol. It is a method by which any host or a router or a LAN can dynamically learn the MAC address of another IP host or a router on the same local area network. Okay. ARP defines a protocol that includes ARP request, which is a message that makes the simple request. If this is your IP address, please reply with your MAC address. Very simple statement it is. That what it says in the ARP request, if this is your IP, please reply with your MAC address. Correct? Now, ARP also defines the ARP reply message, which is indeed lists both original IP addresses and the matching MAC address. Means if I am sending the request, I need to get a reply. So whoever is having that particular IP address will reply with its own MAC address. What it says, note that hosts and the routers remember the ARP results, keeping the information in their ARP cache or ARP table. So what we call it is a ARP cache or ARP table we can call. So whenever you're checking the ARP cache in the Windows, what command you use? ARP space -A. In the routers, we'll use SOARP. Okay. In the switches, we have MAC address table. So this is explaining you that we have a certain host A, host B, host C, and host D. So it sends a ARP request to all the hosts, and it is sending it to the host B to ask to know the MAC of the host B. So everyone will receive the request packet, but who is replying? That particular host B only will reply. Okay. Then it is explaining you what is that ARP operations. So it says that we have ARP request, broadcast, and ARP request to obtain the MAC address associated with the specific IP address. Then devices responds with their MAC addresses if they match the requested IP addresses. Correct. Next, it says this is ARP request, this is ARP reply, and all this information you will find here. Target MAC is what? Unknown. Where we find this? In the ARP header. Clear till here? Now what happened? Let's say we have taken one switch. With that, we have connected two PCs. Okay. Now, this PC1 is having IP 10.0.0.1. Same as this PC1, PC2 is having IP 10.0.0.2. This time, different IP, right? Now, if they will have to communicate with each other, what they require, ARP request, then they have got the ARP request, everything. They have maintained the ARP cache, ARP table. PC1 is also maintaining that. PC2 is also maintaining that. Now, what happened later on, that you change the IP of the PC2. What you did? You change the IP of the PC2 from 0.2 to 0.3. But still that PC1 will be maintaining the same information that I have a neighbor that is 10.0.0.2, and this is the MAC address, let's say triple B or triple anything. So now, but what you did, you have changed the IP of the PC2, but you have not informed PC1. So even if they are maintaining the ARP cache, they will able to communicate or not?
Yes.
No, the PC is not, IP is not there. No. What will you do? That is not matching now. It is not matching. So what is required? So whenever there is a change in the network, that change has to be updated to that particular neighboring devices. Correct?
Yeah.
Let's say, for example, you have a group of 5 friends. So among that 5 friends, one person has changed his location. So if he has changed, so he has to update all his friend members. That see, this is my new address. You have to come to this address to meet me. Right? So if they will not update his neighboring devices, let's see, my information has been changed. So how they will communicate? So that is done with the help of what? Gratuitous ARP. Gratuitous ARP. In this, what happens? That whenever there is a change in the any of the devices, that devices is responsible for sending that update to all other devices located in the network. Right? So this Gratuitous ARP, or in short, we can call it as a GARP. GARP, it is used to send the updates. It is used to send the update to the devices in the network. Okay. So whenever any address of any specific device has been changed, then that change has to be updated to other devices. And for that, GARP is used. Okay. And it sends the update in broadcast form. It will send the update in what form? Broadcast. It means it wants that whatever the other devices is there, they all should know that this is my new address. Okay. Next thing, GARP, it does not require any request. It means no one is asking him that send me your update. He himself sends without any request. But in the app, what we require, always request, then only we have a reply. But in this, it is not any request. It does not require. If there is change, it will send. Apart from that, GARP is also used to detect duplicate IP address. It means that let's say this PC1 is having IP 10.0.0.1, and by mistake you have again assigned the PC2 also with the same IP. It will not take that IP. What it will say? Already this IP is in use in the network. It means who is going to reply this? GR. That duplicate IP address has been detected. It means that here GRP is responsible for sending the updates. Apart from that, even detecting the duplicate IP addresses. Clear? See, it's in the PPT. So it says here that GARP is a variation of the ARP where a device sends an ARP request packet containing its own IP addresses and MAC addresses mapping. Who sends? The devices will send. Used to update ARP cache where on other devices in the same network with the updated information about the devices sending the GARP packet. It means it is used for what? To update the ARP cache on other devices, to inform other devices. Helps quickly avoid IP addresses conflicts, update their ARP tables quickly when there is network configuration changes. So commonly used during network reconfigurations, whenever we are changing the configuration of any of the devices, such as changing the IP addresses or replacing the network interfaces. It can be anything, IP addresses we are changing, or let's say we are changing the interface numbers. For that also, it requires this GR. Okay, now see, let's take one switch. And two PCs will take. Ten dot 0.0.10. Okay, now come to simulation. Come to this PC, desktop IP configuration 10.0.0.10. Then now see what happens. As soon as we are going to assign the same IP, what happened? ARP is generated. And what it says? The frame is Gratuitous ARP request. What it is? The frame is Gratuitous ARP request, and what it says that this is the MAC address, and what is it is in what form? all have broadcast. So ARP request source IP is what? 10, and destination IP is what? Same 10. It means it will send that this IP has been already in use. Okay, and who is responsible for sending that? GR. Okay, same thing we can do it using in the EVNG also. When you will capture the packet, it will show you that this is the ARP request, everything. And GR request. Hmm. See, it is written also. No? Gracious ARP request. The ARP frame. Clear? Understood? What is GR? Clear now? Hmm. Yes, online students, any question till here? No questions? Okay, then we'll understand here Proxy ARP now. See what happens. Let's consider that here we have a router. Then we have taken one switch. This side also one switch. One PC. And this side one PC. This is router. This is switch 1. This is PC1. Next, this is PC2. This is switch 2. This is PC3. This is interface number G0/0. And this is interface number G0/1. We will assign the IP addresses now. So IP addresses on G0/0. On this interface, we have 192.168.1.10/24. Okay. On this PC1, we have the IP as 192.168.1.1. And by default, /24, you know. Here we have 192.168.1.2/24. This side we have 192.168.2.10/24. And for this PC, we have 192.168.2.3. Now you tell me that PC3 and PC1 are in different network or not? How you are identifying this? First thing router, second thing IP also. Based on the IP also you can identify this. Now if PC1 is trying to communicate with PC2, okay, if PC1 is trying to communicate with PC2 directly, what will happen? ARP request will deliver to the switch, then switch will send it to PC2, will get the MAC address, will send it to the PC1. That is fine. It means here in the same environment, same local area network, what is required? Only switch is required. Now, if PC1 is trying to communicate with PC3, for that, what will happen? ARP request is going to be generated from the PC1, will reach to the router. Now, what this router will do?
Send to all.
See here. Now, what happens? This is a scenario. PC1 will send ARP request to the router. Okay. If router is replying with its own MAC address. What happens here? That PC1 is trying to communicate with PC3. Okay. So for that, PC1 is asking the MAC address of PC3. What it is doing? It is asking the MAC address of the PC3. Okay. But in that situation, PC1 is not getting the PC3 MAC address, but it is getting the MAC address of the router. This is called as a proxy ARP. Why? PC1 will send it to the router. Router does not support broadcast. Okay. What it will say, okay, you want to know the MAC address of the PC3. You take my MAC address, you send me your packet, I will forward it to the PC3. Okay. In this, what is happening? Who is replying with its MAC address? Router. PC1 is asking the MAC address from whom? PC3. Reply is coming from whom? Router. This is called as what? Proxy ARP. Right? Now, see, if PC1 knows that PC3 is not there in my same network, it is in different network. So PC1 knows that it is in different network. So I will not ask the MAC address of PC3. I will ask the MAC address to the router. And if I am asking to the router only, and if router is only replying, this is not proxy ARP. Got?
No.
See, if PC1, let's say PC1, see, okay, tell me in this particular scenario, what is the default gateway for this PC1? This one, 1.10. 1.10, this is 192.168.1.10/24, the IP. This is considered as a default gateway for the PC1, and same as this is a default gateway for the PC2 also. It means here they are knowing the default gateway. If they are knowing the default gateway, they will ask the question to whom? To the default gateway only. Okay, right? But what happens that PC3 is in a different network. So PC1 is not knowing the default gateway, let's say. He is not aware about the default gateway. He does not know that. So what he will do? He will directly try to ask to the PC3. Okay, but though he will ask to the PC3, who will reply? Router. In that situation, this is called as a proxy ARP because the question was asked to the PC3, reply we got it from the router. This is proxy ARP. But let's say this PC1 is knowing that this PC3 is not in the same network. And I know my default gateway. And even I know that always if my devices are in the same different network, so who will reply? Router only will reply. So why to ask to the PC3? Let me ask to the router only that, see, I want to communicate PC3. You send me your MAC address. I will send you my packet. You forward it to him. Okay. In this situation also, you're getting the MAC address of what? A router only, but this is not a proxy ARP. Understood? This question was asked. And because of this question only, one student was rejected because he was not able to explain this concept. Okay, he told both the cases proxy ARP only. Okay, depends. That device is asking that question to whom? To the router or to the PC, right?
So how will router get to know to which interface it has to send?
Because see what it will do, that it knows that this is my 1.1. It is information is coming. So each interface of the router is considered as an individual network. This is one network. This is one different network.
Yeah.
Okay, so it knows that this if this is coming from any information is coming from this PC, it means it is in my this network. So it has to send it to this only, and then switch will reply to the PC1.
No, how will it get to know that PC3 is in that network? I have to forward it to that.
Because see here, it is written no 2.10. I am asking to whom? 2.3. Because of 2 only, it will identify this is my second network. It means my PC3 will be this side only. Right? No, that's why I told you. This is which network? This is network 192.168.1.0. Okay. This side 192.168.2.0. So if 2.3, it means it is a part of what? 2.0 only. And 2.0 is which side? G0/1 side. That's why. Correct?
Again, if there are 3, 4 PCs,
No problem.
again unique as flirting, then it will go.
See, it will further, what it will do, it will send it to the switch 2, it will broadcast, collect that information, will reply to the router. Okay. See what is written here. Proxy ARP is a feature where a router or device answers the ARP request on behalf of another device, essentially pretending to be the target by replying with its own MAC address. And in this situation, who will reply? Router will reply with its own MAC address. So proxy ARP can allow the communications between devices in different subnets without changing their IP configurations. The same scenario will take. We'll take this router 2 and 1 1. Then one switch this side, one switch this side. Come to this PC, 2 PC, and this side 1 PC. IP is what? 192.168.1.10. Here we have taken is 192.168.1.1. This one is 192.168.1.2. This side is 192.168.2.10. And let's say this is 192.168.2.2. Last one. Okay. Or sorry, 10. Correct. Fine. Now come to this router. Assign the IP, CLI. Give no enable config space T. Okay. Host name, it is not mandatory. Interface is what? G0/0. IP address is what? 192.168.1.10, 255.255.255.0. Give no shut, give exit. One more interface we have, that is G0/1. Interface G0/1. IP address 192.168.2.10, 255.255.255.0, and give here no shut, give here exit. Okay, now you come to this PC, desktop IP configurations, 192.168.1.1. Okay, come to this one, desktop IP configurations, 192.168.1.2. Next, come to this one, desktop IP configurations, 192.168.2.2. Ping to 192.168.2.2. Not pinging. Why? What is required? Default gateway is required.
Default gateway.
What is the default gateway? When you will try with this in the EVNG, the message will change. Okay. For the first time, it will tell you host unreachable. Right? Default gateway was missing. For the second time, it will tell you request timeout. But here Cisco packet tracer, both the messages are request timeout only. Okay, but when you will try with EVNG, it will also change the messages. Now also it is not the reason you have given default gateway only on this PC. What about this PC? Even it should also know the default gateway, no? So for this PC, who is the default gateway? 192.168.2.10. This one. 2.10, this one. This is a default gateway for the PC 3, right? Now, let's see if we try to ping what will happen. Come to simulation mode. Come to this one. Now you try to ping. Okay, the main problem already it has got the request. That's why it's showing you like this. Okay, let us try to ping it from here. 192.168.1.10 default gateway. Now come to simulation and command prompt ping to 192.168.2.2. See here what happened. This is what ARP. This is what ICMP. Now see ARP. All F 01. Okay, now see what happens. Deliver to the switch. Now see what switch will do. Broadcast. One is to the router, one is to the PC. Now see what will happen. This router will reply with its own MAC address. As of now, yes, this is what source MAC address. This is what target MAC address. Okay. Now see what this router is doing. What it did. Send back to the switch and deliver it back to the PC. It means it is not going to send it to the router. But what if you will send the ICMP packet? Delivered to the PC. Now you see. Come to real time. Come to command prompt physical config fast Ethernet. This is the MAC address of what? PC3. Okay, note it down. MAC address of PC3. Now come to that device. See here now. Give exit. Okay, first you come to this one. Command prompt. Give ARP space -A. This is what MAC address it is learning. Who? PC2. Is it going to say it is not matching? No. This is the MAC address of the. This is the MAC address PC2 is learning, Whereas here we have written MAC address as this one. They both are not same. It means here it is not getting the MAC address of the PC3, this one. It means it is getting the MAC address of what? Router. How will you check on the router? Show ARP. When you have given this command show ARP, what it says that 1.1, 192.168, 1.1 is having this as a MAC address. 1.1, who is 1.1? PC1. This one is 1.1. It is knowing this MAC address. Yes, it is knowing. Next, 1.2. What is the MAC address for the 1.2? This one. And what it is? 1.10. It means gateway. Each interface of the router will be having a MAC address. Okay. But when you will observe here, that by default MAC address is all common only, but each interface is changing with what? Just numbers. Here we have 1, here we have 2. Correct? And this is what this particular device is getting. CA01. And here what we have? CA01 for what? 1.10. Correct? If you will check on the PC1 also, let's check on the PC1, this one, ARP-A. Same CA01. It means if you have here 10 PCs, this side if you have 10 PCs, and if you want to communicate with any other PCs of other network, all that 10 PC will be having the MAC address of this default gateway only. Correct? And this is called as what? Proxy ARP. Why? Because a router is replying with its own MAC addresses, not the MAC address of the PC. Correct? And in this, what happened? It is even asking it to this PC only. That's why this is only the proxy ARP. If it is directly asking to the default gateway only, and if default gateway only replying, then this is not a proxy ARP. Correct? Understood this part? So even if you will take here, let's say one more device. One more switch we have taken, for example. One more PC. Let's say we have taken 192.168.3.10. Okay, same /24 for this interface. And for this PC, 192.168.3.1/24. Okay. Then you have to come to this router. Config space D. Interface G0/2. What is the IP address? 192.168.3.10, 255.255.255.0. Give no shed. Give exit. Now check do show IP interface brief. If you will check here, these are the IP that has been configured on individual interfaces of the routers. That is 0/0, 0/1, and 0/2. And all the IPs are of different networks, right? So each interface, different network. Now come to this PC. Desktop IP configurations. 192.168.3.1. And here what is required? 192.168.3.10. Now, even if this particular PC is trying to communicate with this 3.10, what it will do? Whom is going to ask? Same default gateway. So if you try to ping to 192.168.3.1. This is the destination. Okay, this is MAC address. Already it is knowing the MAC address. That's why it is maintaining that. That's why it is not requesting that, because already it knows that I am asking to whom. Okay, so if you will see here, what is my target MAC? This one only, right? And here, if you will see in the IP, we have all source IP is what? 1.1. Destination IP is what? 3.1. So when it will send this packet, delivered to this, because it is ICM, right? Now, when you will check on the PC, see, for the first time, there is a loss, no? Request timeout. Then, like it sent 4, received 3, lost 1. Why it is not 100%? Why it is 25% loss? Because one packet is lost in the ARP. Okay. Because see, we are checking with the simulation mode, no? So it is showing you ARP packet separately and ICMP packet separately. But when it sends, so in asking that a MAC address information only, it drops one of the packets. That's why it is 25% loss and 75% successful.
Second time it will be 100%.
And second time it will be 100% because already it is knowing that information. So if you will check here R hyphen A, so what it says, every time it is maintaining the MAC address information of what? Of this particular interface only. Getting the point? Always it is going to maintain the MAC address information of this particular interface only. Even though it is going to communicate with this or this, but it will ask to whom? To the default gateway only. Got the point? And all this is acting as what? Default gateway. If this particular PC has to communicate for this PC, what is the default gateway? 3.10. For this PC, what is default gateway? 1.10. Same as for this one, 1.10. For this one, 2.10. Correct? Okay. So what is the meaning of default gateway? A default gateway is a router or a network device that acts as an access point or exit point for a device to communicate outside its local network. So whenever device has to communicate outside its own network, for that it requires the default gateway. So devices on the same network can communicate directly, means devices on the same network does not require default gateway. But if the devices wants to reach a different network, it needs to send the traffic to a default gateway, which then routes the packet appropriately. Okay. So whenever you have multiple different network associated with single routers, then default gateway is required. But if you will take here 2 routers, then different networks, then default gateway will not be enough to have the communication. What is required? Routing. Okay. So when you have more than one router and then different network, then routing is required. This is also a part of routing here because we are evaluating the communication between different network, but it is based on only the default gateway, not the routing. We have not used any routing protocols here. Correct? So note down all the points now. An ARP request is generated asking the MAC address or not, right? For the ARP request is generated for knowing the MAC address of the device located in different network. And if router reply with its own MAC address instead of sending the MAC address information of the associated device, then it is called as proxy. Okay, same thing. When devices are located in different network, an ARP request is generated for knowing the MAC address of the default gateway. Okay. And if router is replying with its own MAC address, then it is not proxy ARP. Right?
What do we call it? Just ARP.
Just ARP. Getting the point? If PC is asking to the PC, tell me your MAC. Router is replying proxy ARP. If PC is asked to the router only, tell me the MAC, I want to communicate with other PC, then this is not a proxy ARP. What is default gateway? It acts as an entry or exit point on the router for the devices located in the network. If devices are located in different network, then to have the communication between them, default gateway is required. Each interface of the router will be acting as default gateway for the specific devices.
It will have it.
If devices are located in different network connected with single router, then default gateway is enough to have the communication between them. But if there is more than one router, then default gateway is not sufficient, you can say sufficient or enough, sufficient to have the communication. And here a routing is required. So this way completes proxy ARP, ARP, Gratuitous ARP, ping, and default gateway. You want me to start telling it?
Okay. Contact indexes which we have one dissolve scenario, these are from Proxy ARP. Then we will show the one example of non-Proxy ARP. Non-Proxy ARP.
For that, we require, okay, for non-proxy ARP here also we can say it is like a non-proxy ARP only because it is asking, if you will see here, the target MAC address what? This one only. Target MAC was the interface of the routers. It was not asking to this PC. So it cannot be the proxy ARP. Though, or let's say whenever the default gateway information is missing on the PC. So if default gateway is missing on the PC, he does not know default gateway. So how to ask to a default gateway? In that situation, always it will ask to the PC only. Because I don't know the default gateway. And in that scenario, if router is replying, then that is called a proxy ARP. But if default gateway is present, so it will ask to whom? Default gateway only. Okay. That's why it is said that this proxy ARP can be removed when you give actual information to the devices. Always proxy ARP is not there in a scenario. Okay, we can overcome with that with the help of actually assigning the default gateway information and enabling the routing. Because here routing is not required. The reason? Because we have only one router. If you would have taken multiple routers, even you have to do proper routing. If proper routing is not there, again, the scenario will take. Okay. And generally we can do it with the help of packet capturing in the EVM. Here it is just doing use simulation, not packet capture. Okay. Which one? Paint file.
So if you're asking PC1 directly
and
the router is replying, it will reply with both IP address and MAC address because you do not have the information of default gateway.
Means again tell.
You're asking PC3 directly through PC1. So it will go to the router. The router will reply with its MAC address and both.
No, own MAC address.
Only
MAC address.
Because PC1 will not have information of default gateway.
See, if it is directly connected, it is knowing that this is my default gateway. We have given him the information regarding that. Okay. So in that scenario, it is going to show the MAC address information. No? ARP is for what? Knowing the MAC of with a known IP.
So we don't know, like while entering in PC, we haven't entered that IP.
Hmm.
So
Ah,
what will happen? How
Then
do we learn?
see, in that scenario, if this PC we have not given the default gateway information, right? In the real scenario, when you will not give in, if you will not give the default gateway information, randomly it will ask to all other ports because it is in the broadcast form only. So when it is in the broadcast form, who will reply? The route interface will reply in the MAC address only, not IP. Okay.
So we'll
Then
have
only we
to
have to specify the information. Clear? So I'll stop recording.